4 years ago, the Severn Trent Water Authority began to control. In winter, excess river water would be stored in a reservoir, then in summer allowed to run back down into the river, and in this way improve the water supply of the East Midlands. As the engineers designed the scheme, they didn't foresee the extent of the problems that lay ahead. To get the water up from river to reservoir, a 5-mile tunnel had to be dug, and there they met the problems. The job was given to a contractor who planned to dig the tunnel in 2 sections and join them with a length of buried pipe. It is the biggest tunnelling contract in Britain and has turned out to be a costly headache, which is still a long way from being finished. At its top end, the unfinished tunnel exit, or portal, is at Carsington. Near the portal, they are building the dam which will hold back the reservoir. It's an earth dam built in strips. Dam building began in 1981. By late summer last year, it looked as if the dam would be finished long before the tunnels could supply it with water. The tunnel contractors, John Molam and Company, were already 6 months behind schedule. Down at the bottom tunnel at Portal D, the tunnelling machine broke on hard rock. At the other portals, machines have been flooded or buried. Molam's foreman, Rocky, on the left, is a veteran of 30 years of tunnelling, and it's his worst ever tunnel.
It's been a big disappointment to everyone here, staff and the men here. There's no 2 days the same. Ground conditions varies every day. Portal D, some days you use 100 pound of explosives, the next day it's coming at you. The same in there. Sometimes you get good days, bad days.
Well, what's wrong with the job as a whole? I mean, what's the problem with it?
Well, ground conditions. Ground conditions and water. We just can't cope with the water at the moment. So there is a lot of water in the area that we didn't know anything about. All being well, we might finish it in about 3 years. All being well. We don't know. Just bad.
As well as the 2 main tunnel lengths, there's a short run from river to pumping station reached by a shaft. 10 yards in, they had to stop digging because water was washing away the tunnel face. To keep the water back, Molam's put in compressed air. So the men have to go through this airlock. It's the only way in and out of the tunnel. When the airlock pressure reaches 5 psi, 5 pounds per square inch, it's equal to the tunnel pressure. Inside, there are 20 tons of air pressure on the tunnel face, keeping the water back. This is a short 200-yard drive, so it's always been planned to dig it by hand. Tunnel digging is not just an ordinary labouring job. These are skilled men who've moved round the world, from sewer tunnels in Birmingham to the London Underground to the Hong Kong Metro. The face must be vertical. Here it needs support with boards. If more than 1 or 2 are removed at a time, the face might collapse. The men work inside a steel shield which protects them from falling earth. The shield is a cylinder on the left, and behind it, the tunnel is permanently lined with concrete rings. Steel rams press against the rings. They are drawn back and a new ring built. Then the shield is pushed forward into the freshly dug tunnel and another concrete ring is built. Each time the cycle is repeated, the tunnel grows by 30 inches. As long as muck goes out through the airlock, tunnellers know all is well here. But in each of the other tunnel sections, there are problems. Tunnelling is a risky business. Contractors often lose their profits or even go bankrupt. For instance, putting in the compressed air cost an extra £100,000. So contractors like Molems have always quoted high to cover their risk. Now it's different because the risk is shared more equally between contractor and client. This is the first major contract under a new code. It's not the contractor who will have to pay the £100,000 for the compressed air system, but the client, the water authority, and, ultimately, the ratepayers. The same goes for many other increases in costs. Under the new code, completed tunnels should come out cheaper than before, because Molem's contracts manager, Hugh Doherty, should be able to quote lower prices and still be sure of a profit. Hugh Doherty will only get his profit if he ensures that the precise drawings eventually lead to efficient digging of the tunnel. Once down with the tunnellers, he's prepared to adapt the drawing board design to suit the conditions.
There's a water table, man. Well, they've not got it secured properly at the moment. Now, I don't want to frighten you on it, but... Oh, no, that's okay. See, that material is very, very strong. Normally, if you've got a shield like this, you wouldn't be working ahead of the shield because it defeats the object of the shield. The shield should be able... The shield is here to support the ground. The only reason they're working ahead of the shield is because the invert's so hard. So when the material's too hard for the shield to cut, then they've got to go ahead and cut it out by hand. If they do that, they've then got to go ahead of the shield and support the roof.
However rough and ready their methods, the tunnellers must make sure they stay online as the shield is moved forward. It's gone offline, so the lead miner has to steer the shield on the next forward shove. There are 8 hydraulic rams at the back. By pushing more on the right side ram and the bottom one, he steers the front of the shield to the left and up an inch or two. As long as the shield can be got back online by trimming, everything is all right. But there are to be spectacular problems in the coming months when one of the shields goes right off course. The shield is a temporary support, and as it moves through the ground, the permanent lining of reinforced concrete is built behind it. These segments form a ring which is designed to last for 100 years. The tunnellers are on piecework. If they complete the cycle of digging, shoving and building a ring twice during their 8-hour shift, they earn £85. So they gross over £400 in a good week.
Up you go. Up. Up again, Lord. Up. Up.
Directly above is the A6 trunk road. The tunnel is only 15 feet below, and despite the air pressure of 5 pounds per square inch, water is still seeping down.
Still there. The water's coming in because really we've not got a high enough pressure on. We're working about 5 psi just now. We should really increase it to about 7 psi and that would dry it out. Because we've got some very low cover under the A6, if we increased it by another 2 pounds, we'd be in danger of really blowing the roof. So we just, case of balancing it. We can live with this because it's not creating any instability in the tunnel. It's a bit messy where they're working, but apart from that, it's safe enough.
The engineers act for the client, the Water Authority. Fred Pearson is the deputy resident engineer. His company designed the tunnels, and it's their job to ensure Molums finish them as conceived. So Fred Pearson's position between contractor and client is sometimes uneasy. It was the engineer's idea to dig by machine. Like Molums, they've now got to adapt to hand digging.
The job, it's a problem job. The problems are very, very, very great on the job. They're very, very, very difficult to solve. They're not. It's not the sort of decisions that people can just go along and say, oh well, you know, we'll change that JCB and put a different sort of excavator in. You can't do it with a tunnel. The equipment is there. It's an inline operation. The whole thing sort of starts at the face, and that face has got to advance. Now. The problems are very difficult. They're big problems.
The plan was to dig each of the main sections of tunnel using road headers with revolving rock cutters at the front. 3 of them have been abandoned. Here at Portal C, the next one up from the river, there is a spectacular problem. In July, the machine flooded and it couldn't cut the hard rock. Now, in September, this shuttle car is all that's left of the original complex digger system. This end weeks. Instead, they're working ahead of it. The tunnel roof is completely unsupported. Normally, it's impossible to see the front of a shield exposed during a tunnel drive. This work has held up the advance and will eventually create an issue between G.H. Hill and Sons, the consulting engineers, and Molums, the contractor, about who will pay for the delay of several weeks. But why have they gone to the trouble of digging this cavern at all?
Well, at the moment, the shield is 600 mil higher than it should be on line, and is 6 inches right of line. So what we're going to do here is, in this chamber, which is 7 meters long, we're going to drop the shield 2 foot and 6 inches to the left, so that when we're sat down here on this concrete cradle, we'll be sat exactly on line and level, and then pointing in exactly the right direction to go forward again.
The tunnel began to go offline when the machine was flooded. They took the digger out, but left the shield and muck conveyor in place. The curve in the roof eventually stopped the shuttle car getting through. They've blasted out the cavern ahead of the shield. Now, 16 tons of steel have to be manhandled down into the cavern, and then the rings replaced behind it to straighten out the tunnel. Whose fault was it?
You can blame a lot of people, really, but it was basically rock. It's very difficult to steer a 16-foot shield in rock. You don't have to make much of a mistake in your excavation, because we excavate 3 feet in front of us each time, and we shove it 3 feet. But if you leave a nib of sandstone, which is what we're in, either at the bottom or at the side, you know, you hit that sandstone, it doesn't give, it just pushes you either to the right, up or down. And steering shields in rock is not easy. You know, one mistake and you're on your way up or your way down.
A mid-September morning. Today, at last, the shield should move. Both contractor and engineer are anxious because they've never done anything quite like this before.
My name's on the drawing for this, whether this thing goes down the bottom or not, and we're about to start moving it now.
So what are you particularly worried about?
Whether it goes smoothly or not, and whether it does actually move or whether it hits snags on the way down or what.
Near enough. It's only a wee bit.
Yeah, it's only that nib. I mean, the rest, that's all free.
It ain't touched that yet.
No, once it's kicked, with a bit of luck, it'll start to roll it across. Kick it across.
They'll take it enough out of the way of that.
How am I doing on these bottom ones?
That's about... Look.
We've had you, right?
Another quarter inch on that bit.
Yeah.
That's before you even touch there.
Before I kick down to that one.
Yeah.
Oh, that's all right, then, isn't it?
Near enough.
It's a bargain.
Near enough for a padding.
Behind the shield, they've already shoved the full extent of the rams. To get any further, they'll have to lengthen them somehow. The lead miner will have to check and control the shield's angle as it bumps down over the rock.
Put another ram on over there.
Timber in there somewhere.
Railway sleepers are jammed in, so the rams can still push against the concrete lining. As the shield grinds and jerks forward, the rock is exposed behind it. A fall here would cut them off. Another 15 feet to go. John Worthington is still worried.
Which number? Which number? Not back to the left.
With 10 feet still to go, railway sleeper technology has failed. Now the shield is to be dragged forward. Holes are burned in the front to attach steel hawsers. Rock bolts, sunk 5 feet into the face, secure the other end of the hawsers. The rock face may be giving way. Finally, the shield's in place. But a large gap remains between the shield at the bottom and the roof of the cabin to be filled with gravel and cement. It's 7 a.m. 6 weeks later in early November. Fred Pearson arrives. He's been phoned up several times during the night by Hill's staff on site. He's reluctantly agreed to let Molems blast ahead again, still leaving gaps between the rock cavern and the tunnel lining. His colleagues disagree with his decision.
Yes. Well, when you take into consideration the weight of that shuttle car, when it's loaded and those inverts not grouted,
All right.
You know, that's what you want to consider.
OK. I'll gear up now. I'll come up there. OK?
Very good.
On his way, Fred meets up with Molam's deputy manager, Peter South.
Charlie's very upset. He thinks it's a very, very foolish thing to do to go ahead with the rings in the state that they're in.
The grouting up has got to be done. I want an instruction on the timing of that work.
No, Hank, listen, shut up.
Rings is 6 months bloody work, yeah?
You're not saying any time. You're not giving us a time when you're going to do it. That's half the problem. But anyway, notwithstanding that, there's such a strength. Yes, but you wouldn't finish it. There's such a strength of feeling on our side that this needs to be done at the moment that I'm prepared to write an instruction out to you.
If you're happy to do that, that's fine.
But I think it's your responsibility anyway.
If you are happy to give me a written instruction, that's fine.
Molams want a written instruction to claim extra payments for the filling work, so Hills may have committed the Water Authority to more expenditure.
I'll show you the calculation.
It worked out as 20 tonne for the... 16 tonne for the first holes, and about 8 for the second.
Fred Pearson's staff are convinced that unless the holes are filled tight, water will soon find a way through. Molam's opinion, based on greater experience, is that there is no hurry. The face, just blasted by the night shift, is a jumble of fallen lumps of rock.
Yeah, but I think a lot of that water is coming from the back, you know, Peter. We've still got water beyond us at the back that was never tackled. Ever. Was it? I mean, we're still...
It's quite a way back now, though.
I know, but I mean, if we're not keeping the rings tightened up, you're going to get that water coming with you.
I agree with you there.
OK, well, we're going to have to stop and tighten this work up now.
We need to grout up.
Right.
Okay. So we're giving us an instruction.
Right, OK, then. So that's what we're going to be doing.
Grout. At the back. Grout. Back grout.
Great enthusiasm there.
There is quite a lot of water coming out of the low joints now, and also out of the grout holes. Yeah. So what I've done, I've told Peter South that we want the work tightening up. Yes. So that's it. They've effectively stopped, and they've just got to carry on and do this back grouting.
Well, when he spoke to me last night, he said he thought that they might run out of pea gravel.
Yes.
And I said that if that was the case, then they'd have to fill it up with ground.
Yes.
So,
George Horn is the resident engineer, Fred's boss.
You know, doing the job properly.
Well, the trouble, if we don't tighten it up, and we do, I mean, all right, I know we've done one round there now, and that presumably needs clearing out and getting ready, and then they should be in a position then to move the shield on. But if we don't tighten it up now, and we do lose any ground from over the top of us, we're quite likely to bring the water down on us.
Yes.
You know, I think they're right. I think we've got to stop and
yes. Well, the normal practice is when you put pea gravel in, you can leave it, but if it's going to drag voids with you, then it's not the same situation at all. And I think you've just got to do what you said.
Okay. Well, I've told him anyway now, so
fine. Okay.
That's what they're doing.
Lovely.
So the resident engineer issues the instruction. The argument rumbles on through the morning, but Molams feel they've got their way. So even their general foreman allows Fred to let off steam.
They said, no, carry on, we'll sort it out in the morning.
Right, what happened last night, I told him he could fire the face, right? He's not shoved the shield. I don't think. He's pushed that ring back. But we would sort it out this morning. Well, we've decided this morning that we want it tightened up, which was what you proposed.
Yeah.
Bloody 3 weeks ago. Why the fucking hell we have to go through all this exercise in arguing the toss about it when it's already... The proposals have already been put forward and agreed. We've agreed what we're going to do. Yeah. And then all of a sudden it's changed. We want to do this, we want to do that. Yeah. Well, that's the problem, Stan. Yeah. If you'd stick to what you say you're going to do, and then do it, and get on with something else after that, but don't bloody change the thing all the time, which is basically what happens. Isn't it?
Yeah. So it's just so much recorded on this job. Another job, you just normally get on with it. But everything has to be written down.
Yeah, I know.
People have to go and see people. And so normally it wouldn't happen.
What's happening at sea? You had a bit of a dispute.
A bit of a bloody rear up this morning. We're stopping for grouting, Alan.
That's good.
We're going to tighten those rings up.
It's HD. I'm confident that you're going to pay for it anyway, you see. So.
Why? We don't accept and we never have accepted that the misalignment of the shield
I'm confident that you'll have to.
is our responsibility.
I'm confident that you have to.
Pardon?
The whole job in sea for the last 4 months, you'll end up having to pay for.
Well, you know, that's fair enough. I mean, I don't think... it doesn't need you and I to argue the toss.
No, it doesn't. No, it doesn't.
But the toss is still being argued between the senior engineers in Hills and Hugh Doherty of Molems to see who will pay what. They often stop to grout. It's a cement slurry which they pump through holes in the concrete lining. Hills insist on grouting up tight because they want the lining to last for 100 years. But time spent on grouting can cut into Molem's profits. And Hugh Doherty argues that their century and a half of tunnelling experience makes them better judges of what's needed. Yet in the end, Molems are bound by the contract.
It so happens that the documents, the specification that the consulting engineers produced is reasonably onerous insofar as we are restricted in mining forward by the fact that we have to tighten up behind us, and they lay down parameters for that. Now, they may be conservative parameters. In this case, we felt those parameters were conservative, and we felt that they could be altered to gain advantage on time. The resident engineer and the consulting engineers didn't consider that to be the case. There was an exchange of opinions, but in the end, if the documents that we're working under states that we have to do it in this manner, and the engineer wants to apply that, well, we will comply.
After the discussion that we had on it, I think that it was agreed really by all parties that probably the right decision had been to tighten the works up at that time. The contractor might have been able to gain something in his production cycle by carrying on and tackling that work at a future downtime situation when work wasn't being carried out at the face, and he could have taken advantage of that time. But it was a marginal situation.
This is the only tunnel left with a machine digger. Here grouting is equally important, but it's cramped in compressed air and the temperature is 80 degrees. There are often delays. This time they've got a problem with the pipe or bag carrying the grout.
This bag's blocked somewhere. Must be. Are you sure there's no Stilsons in there somewhere?
I don't know, Ron.
Nobody's looked for any in the ship.
Nobody asked.
Yeah, go and check that out.
Right, we've got a pair of Stilsons here. I'll send Paul up here.
With the notebook is Hill's site engineer. He makes sure the tunnellers don't skimp.
Right, try it now. 1 minute after all that,
Grouting can increase the time they take to reach their target, so they'd prefer the other shift to finish it.
As soon as they've done this, I'm going to watch them build, put the ground.
Until Hills are satisfied, grouting continues. By the late autumn, down at Portal D, the one at the river, there's a regular productive routine. At 7 a.m., the day shift arrive from their caravans or local.
Yeah? Yeah?
This hard rock tunnel, D, has been steadily getting longer ever since the summer. It's now 1/3 of a mile long, and the muck keeps coming out. Next to D is the other success story, the short hand-dug tunnel. It's now well under the A6 and past the water, so the compressed air has been taken out. They are only a few feet from their goal, the pumping station. The pumping station side is completed and the face boarded up. Auger holes show that the tunnel is only 2 inches offline. The breakthrough is usually a climax, but there's still another 4 miles to dig in the main tunnel sections.
How long's this tunnel taking?
Get the 7-pound hammer.
This drive?
7-pound hammer.
About 7 weeks.
And has there been any problems?
No, none. You're better off in this handwork than you are the diggers. The machines break down, the man is done.
So, what happens now?
We'll finish this, then we'll go to section B. That's what works with. That's the digger section.
How's it feel? Finished one.
It's all right.
So you're going to...
They promised us 4 bottles of whiskey, there's only 1.
You got a wedge in there. Don't think so. There, get my wedge. Yeah, you bro.
It's winter. Most of these concrete ring segments should be lining the hole. The tunnels are a year behind schedule. It's taken a long while for Molems and Hills to agree on new methods and their costs.
We should have been in the position now when we would have been looking for completion of the shorter of the drives before very long now. Because it takes so long to decide and to gear up and to carry out the tunnel advance in a different way, it's bound to lengthen the contract. That's bound to have an effect on cost. If a contractor's on the site longer than he would have thought he would have been, there's bound to be cost implications in it for him.
Our contract is run up for a certain price. Of course, that is not necessarily the budget price. Because the engineer and the client, having assessed that there's the possibility of doing more grouting or having degrees of problems and difficulties with the ground, we'd also do an estimate as to how much that would cost. It's a risk element. Therefore, they have a budget to cover for these difficulties. When, if we don't encounter the difficulties, then they don't spend the money. If we do encounter the difficulties, then one has to spend a bit more money.
Well, the money will have to be found by the client to pay for the work, or the money will have to be found by the contractor to carry out the work that he's contracted to carry out. It remains to be seen, I think. It's not exactly finalised as to where the money will come from, I mean.
And they are trying not to waste any more. In the early days, the client and engineer thought they had drilled enough boreholes for a survey along the tunnel route. But that original survey led to the decision on machine tunneling, which turned out to be a costly mistake. Now everyone realizes they need to know more about the hardness and condition of the rock all along the tunnel route. Only with a complete rethink of the geology can they be sure of buying the right equipment this time.
I would again re-stress that the overall assessment is very, very important, because to get equipment, if we talked in terms of going on a, say, drill and blast, and say it was on to shuttle cars or hag cars or some form of equipment like that, we don't get that equipment in about 1 week's time. I mean, the lead-in for shuttle cars could be something in the order of 3 months. So, I mean, if we're, in the short term, if we clear the air on what we're doing and we're working positively there, not that we're not working positively now, but, I mean, if we beef up the advance in the short term in this area, we've still got to be placing orders for equipment for the long-term situation. Because, I mean, with a three-month lead-in, well...
Yeah, I agree with you, but...
Paul Brooks is Doherty's opposite number in Hills.
The long-term geology has got to be reviewed, and I would be looking for our geologists and your geologists to agree on a new section.
Yeah. And that done in parallel with the boreholes, and also done, I mean, if it means committing more geologists to it, we'll all do it. I mean, what's the cost of a few geologists compared with the sums of money
it's the time of getting the information, Hugh, is going to be the problem. It's the actual time of getting the information out of the ground. Now, we're going ahead with another rig now. I was speaking to Jim about it this morning. The intention is to gear 2 rigs up to the harbour top, but you're still talking about a month's drilling for 2 rigs.
Yeah.
No one will say why the consulting engineers did not reach the right conclusions from the original boreholes. Possibly the first drilling company didn't treat all their cores carefully enough, or they were badly analysed. In any case, the combination of wrong judgments led Molems to buy wrong and costly machines. The new survey was complete by the late autumn, and new equipment was ordered. But tunnellers have a saying that the only truly reliable survey is the tunnel itself. In the only machine-driven tunnel left, there was some truth in that saying. Back in the autumn, the machine at Portal B was driving through weak mudstone and water. At 10 o'clock one morning, Molem's site manager, Jim Swanson, was called to the face.
And when I got here, there was about 20 gallons a minute or so coming in from the top left-hand side of the face. It had taken with it some quantities of soft mudstones and shales, and was continuing to take some silty material with it. As I got to the face shortly afterwards, the flow very quickly increased to about 10 times its original volume, and there was quite an inrush of blocky mudstones and bits of broken rock, which virtually filled the shield, coming right back, washing broken material right back into the tunnel. The flow of water was probably of the region in excess of 100 gallons a minute at that time. We had little choice but to abandon it temporarily anyway, and pull the men back from the face until such time as the flow stabilised.
The buried machine at B was boarded up. Straw was stuffed in to stop silt and mud being washed out. It stayed buried for several weeks. Now they've recovered it, once again by putting in compressed air. Advancing the tunnel could be dangerous because the weight of water above their heads could cause a collapse. So a drill's been probing ahead to find the water and then block it by pumping in cement grout.
Slowly back, slowly back. That's exactly what. Well, hold me. Then away.
They've just passed a borehole predicting water-holding rock above the tunnel and slanting down towards it. Drilling and grouting has taken 2 weeks. How much longer is a matter of judgment or guesswork. This machine tunnel is 300 meters into the hill. Ahead is the broad band of water-holding sandstone. As the drills reach it, water's released. That's stemmed by injecting cement. But any remaining water could still collapse the cover of weak mudstone below the sandstone. If the tunnel gets longer, this cover will get thinner and weaker. Should they dig ahead?
What are we going to do now? You're going to carry on injecting that right-hand hole. Yeah. We're going to try and get that other hole across. We'll then do a proving hole down the centre. Assuming that that shows us that we've got a reasonable grout take, what are we going to do? I think we should be thinking in terms of possible a short advance.
Yeah, we're talking about 5 metres, actually, which takes us to
With Fred and his engineer is Vic Wrightham, Molam's section manager.
That reduces cover to about 4.5 metres from 5, if you're at 11 degrees. Yeah. If, of course, you're 18 degrees...
We're right into it almost.
You're getting nearer to the earth.
That takes us to about, what, about here somewhere?
I don't know, where's your position?
There's your front reach.
Is this...
That's 2, 4, that's 5 metres there to that point. Just ignore that bit there.
So we're talking about, what, about 3 metres of cover to the sandstone?
Potential. See, this is why it all becomes rather brave at the end.
All right, it becomes rather brave, but if we've got grout in this zone now, and we can probe into it and find that we don't really hit any major water until we've gone into the sandstone, at least if we've driven it back from over the top of us, we might still be able to get that advance without any great risk.
I agree.
Next day, they're still discussing it in the compressed air of the tunnel itself.
Right, 22 rods, so we're talking somewhere in the region of 14 or 15 metres ahead of us before we hit any water.
Yeah.
And how much water did we hit then?
And that was the 12 o'clock hole?
Yeah, we hit in that 30 metres to start, and we didn't finish it with any more than 75.
No.
Now, the interpretation that we put upon it was that we got too close to the grout zone of the other one. So we'd like to go further. Well, we've already done some on that side, so we'd like to go a wider one still on this side, which we can do.
Certainly, Alan and I felt, when we looked at it, that possibly 10 metres was
I'll
on.
tell you what, we can go and have a look at it.
There again,
upstairs, and you can see them for yourself.
It's Wednesday night and Thursday night, and we're, if we're going to do this advance, we want to get the advance done and stopped by the weekend. I think we're right in the middle of it, do we?
No. But we should be able to cope with 5 metres without too much trouble. In a fairly good time.
All right. We've still got 4 metres between the tunnel and the sandstone, we think.
Yeah.
Even with a 10-metre advance.
Well, I see. So that's 4.5. What dip that? Well, that's
on a 10-degree dip.
Oh, well, we differ there somehow.
Do you?
Yes.
So it's not likely that, I mean, whether it's, whether the air's a factor or whatever, we're not really getting big water makes when we just hit the sandstone.
I think the air is a factor. And the other thing is that if we get into a critical situation where, because the air pressure and the water pressure are starting to get balanced and then run into an imbalanced situation, which you're bound to get through here as the cover gets less. I mean, when it comes, it'll come with a great big wallop, and then the air will be of no value to us.
I don't want that to happen at all. Right,
you don't?
So let's have that right.
What seems to be happening now?
And they did safely advance 5 metres. But in the new year, the road header was pulled out, and now this tunnel is being dug by hand as well. The cost so far has risen from 15 to 25 million pounds, and the contract extended from 3 to 5 years. The water users of Severn Trent will eventually get their summer supplies boosted by water flowing back down the tunnel, but they will have to pay more for it.